Hello. In this video, I would like to work an example for you in which we meet the learning target. I can solve an absolute value equation that contains an absolute value equal to an expression. Let's begin with a quick review on what exactly does it mean when we say the absolute value of a value. The absolute value of 3 is asking us what are values of x that are going to be 3 units from 0. Considering this, you would have -3, which is 3 units to the left of 0, and +3, which is 3 units to the right of 0. Considering the equation in the learning target, they are asking us when you have an absolute value equal to an expression like 3x minus 2. Conceptually, we're asking the same question as the problem in the review. What is a value of x so that when we get this value underneath or inside the absolute value bars, it will be this distance from 0. If we think about this as how we're going to have values to the left of 0 and values to the right of 0, we will take what's inside the absolute value bars and set that equal to the opposite of that distance from 0. And we will also take it and set it equal to the positive of those numbers that are to the right of 0. Continuing to solve these equations, we distribute our negative sign. We isolate our x. And we find that 5x equals -1, so x will equal -1/5. Or, when we take what's inside the absolute value bars equal to the positive value, which is to the right of 0, we have x equals 5. With all absolute value problems, we always want to check our solutions. Check our possible solutions. Because it is possible that we have an extraneous root. In this case, if we take -5 and place it in for x, into the original with the absolute value bars, we will have the absolute value of -2/5 plus 15/5. We must have a common denominator in order to add fractions. Same thing on the right side. -2 is converted to -10/5 so that we have common denominators. Here we have the absolute value of 13/5 equals -13/5. Well, the absolute value of 13/5 is 13/5, and that is not equal to -13/5. So this is a false statement. This would be an extraneous root. Or an extraneous solution. Sometimes instead of the word solution, we might use the word root. With the other part of our problem, we would have the absolute value of 13 equals 13, and this is true. So for this example, our only answer is x equals 5. And writing that in set notation, we would say x such that x equals 5. This was an example on how to solve an absolute value equation that contains an absolute value equal to an expression. Points of emphasis are that we note that absolute value is how far a number is from 0. And we can have values that are to the left of 0, which would be negative, and we can have values to the right of 0, which can be positive. Applying this concept to a more complicated example, we have to note that we're going to use the left side of 0 with a negative, and then we'll also just use the positive for the values that are to the right of 0. Thank you, and have a great day.